My name is Jaime Fink. I am the co-founder, along with my partners here at Mimosa. We're now a little over 4 years in business here, and we have finally really launched the completeness of our portfolio to really be able to offer a complete suite of different communications delivery platforms. And today we wanted to really focus on the latest offering that we have, which is our rural solutions for high-speed fixed wireless internet. So before I get started, I'll talk a little bit about what we've been doing in the last year or so. So the last 5 6 months, we've focused on getting our multi-point platform moving forward. And for those of you that are familiar with the fixed wireless business, it's traditionally made up of both backhaul equipment that delivers bandwidth from a low cost from data centers and to tower locations into neighborhoods, and then of course the all important multi-point technology. And today we're going to be spending a little bit more time working on the multi-point technology, but Mimosa has really been focused on both backhaul and now multi-point solutions. A few months ago, we introduced our first series of platforms, which actually are going into kind of a groundbreaking area of using fixed wireless to deliver broadband in suburban areas or very high density urban markets. Today, we're really going to talk about going back to the really traditional place where fixed wireless was born and where there's just been a culture of wireless ISPs, or WISPs as we call them in the industry, really groundbreaking how you can deliver internet to places where cable and DSL just didn't make sense. So today we're going to walk through a bit of that. At Mimosa, as I was mentioning, I think we're really focusing on 4 different business cases and applications where broadband is going to get delivered. We are going to focus on rural today, but just to make sure everybody is aware of the different solutions that we are working towards. The rural technology, as we're going to talk about, is really game changing in the kind of scalability that Mimosa can now help deliver into tower locations. And rural is traditionally based at towers, whether they be more formal cellular towers or the traditional things that WISPs like to use for serving locations, like grain silos and water towers and hand-built POP locations. But really the focus here is going to be how do we get more speed and capacity into rural areas. As I was mentioning a minute ago, we also introduced our first suburban technology, which is really what we call micro pops that are designed for very short range, high density neighborhoods. You can see an example picture here of a wireless ISP here in the Bay Area in a high density market, really delivering fiber speeds using fixed wireless at a fraction of the cost. We now have a number of people using our technologies in the urban applications, which are really multi-dwelling units and being able to go from building to building. That's probably not our primary focus as a company right now, but we see a lot of people doing this with great success and with great cost innovation. So you're able to really connect buildings before the fiber guys are able to get there and really provide great services, in the multi hundreds of megabits up to a gigabit for a building for people that really need better speeds to apartment complexes where fiber doesn't serve. And the last area, I think we're seeing a huge amount of interest from municipalities and wireless ISPs is the opportunity for ISPs to partner with public-private organizations. So municipalities working together with ISPs to really expand access options and drive competitive options, as well as Wi-Fi for cities, and also gaining access for people that really have really poor coverage, students in connectivity gaps, and other people that are underserved in these higher density markets. So this is really the kind of how we bracket the different serving applications, and really where we really want to drive the ball forward as a fiber alternative in each of these different markets, and really tie them into business and architectures from a technical perspective that are really easy to understand and easy to deploy. So one thing I'd like to touch on before we get into the actual rural application is the kind of key elements to the architecture. For the guys that are familiar with Mimosa already, you'll probably understand these quite well, but it's worth just doing a brief touch on. The name Mimosa actually comes from the word MIMO, and we named the company this because we were really inspired by this new multiple in, multiple out technology that's growing at an incredible pace, which helps us get much more capacity out of the spectrum and serve many more users out of that same amount of spectrum. And that's traditionally called MIMO, or now it's being called massive MIMO by having many more multiple in, multiple out streams. And this is kind of the first key tenet. The second key tenet for us is when you look at wireless in an outdoor area, it typically has not worked well because the different clients in the neighborhood couldn't hear each other very well. When they can't hear each other, they try to talk over each other, and that's really the interference that's caused when you have traditional carrier sensing networks, much like Wi-Fi uses today. And this is where time division, or TDMA technology, comes into play, where we can organize clients and get much better spectral efficiency than traditional carrier sensing techniques, and really make sure that we're going to get the best efficiency out of the air. Now, with that, we then are going to be pairing up this technology of TDMA with our really the critical sauce here, which is the what we call synchronization, or GPS based synchronization, where all of the different radios or access points in the neighborhood and on tower locations can use the same GPS synchronization source and reuse the same channel over and over again. Where traditional, I think, rural and traditional, and now the new opportunities we're seeing in high density suburban environments didn't always use synchronization, that meant that every time you added more base stations or access points, you needed to get another channel for that access point, and that would cause self interference. So the synchronization is helping us eliminate self interference, or plan where we can put these radios very tightly together, as we're talking more about tower locations. And this lets us get incredible spectrum efficiency across a network deployment. And lastly is cloud technology, which is helping us really understand the behavior as we go and maintain these networks for all the different client devices that are out there, and how we can analyze what's happening with the health of subscribers and how they may impact when they have problems, or if perhaps if they're trying to take up too much bandwidth. Or if they're not aimed properly, is a good example. They could cause problems with our overall network. And the cloud helps us understand when these situations are happening and how we can help mitigate both spectrum and subscriber use problems that are causing problems with the airtime. So these are really the four key tenets that we have to the technology that I want to keep in the back of your mind as we talk about these solutions as we go forward. But this is really what Mimosa is all about, bringing these four things together very cleanly and easily, and making it easy to adopt and deploy a network in rural areas, but also in the other applications I was mentioning. So with that, I'm going to jump into the rural opportunity. And this is really a very new technical approach. All of the past deployed fixed wireless solutions in the field have been traditionally two polarization or two stream MIMO technology. And what our new technology, as you see pictured here, is our product called the A5C, C for connectorized. It allows us to put our connectorized radios up on towers, and we're going to show you how this all works in a little bit, but it gives us the first 4x4 MIMO technology, and that's really just the tip of the iceberg. It's the starting point for Mimosa as we move into this very high capacity environment on tower locations. So we're going to start cutting into the different parts of the opportunity with rural. I'm going to start off a little bit around the kind of business challenges that happen in rural. I think there's some very good new data that came out of the FCC, out of their typical mapping programs, as well as other research that they do. But today, if you look at the problem, we still have 34 million Americans that don't have adequate access. And typically that the number for adequate access is, I believe, getting up towards 25 megabits as they would deem for a broadband connection. And that number declines a little bit if you look at people that have slower speeds, but you really can't satisfy the speeds that people want and call it broadband with things like satellite. So people that have satellite really are now getting included in this number because they can't get the kinds of speeds that people want to be able to do Netflix and various different video downloads and interactive Internet of Things kinds of applications with low latencies. Now, looking at it at a global level, if you look at generally population-wise, over 40% of the global population is in rural areas, and the underconnected in the world is quite a large percentage happening in rural areas. So it's quite critical that we really develop technologies and a cost basis that's very inexpensive to make this happen. So let's look at the business drivers. Today, WISPs are challenged on a number of fronts, and I want to talk about those problems and challenges head on. I think that what we see out there today is you have fixed wireless, where most people are offering maybe 5 to 10 megabit plans, and sometimes a little bit faster. But with traditional offers that are out there from the competitors, it's very difficult to get to 25 megabit speeds and above. Now, why is this important? The FCC last year came out with a new ruling that said that you cannot get called broadband and therefore get access to federal monies to subsidize broadband to help you deploy broadband in underserved areas unless it's 25 megabit speeds. So this is a really critical thing to upgrade WISP networks in rural areas to get to. Secondly, the CAF2 funding that's out there from the government, for those of you familiar, this is obviously a program that the government has sponsored to put over $9 billion into subsidizing and promoting fixed technology, whether it be wireless or wired, in underserved areas. And this is based on where the FCC has been told that there is adequate or is not adequate bandwidth. Now, this has been an argument point by many, as you see a lot of the other major telcos in the space come in and claim that they have bandwidth in certain areas. But generally speaking, you're never going to get access to this funding unless you start moving to the higher speeds. The other things that I think are important here are competition. If you look at rural areas and you look at the cellular community, the 4G LTE community easily can deliver in rural areas from existing tower locations because they're underutilized towers, unlike in the city areas where they're heavily overutilized. In rural areas, they're not. So it's quite easy for the LTE community to offer fixed wireless solutions off of their existing 4G based technology and provide competition to what most WISPs have been delivering up until now. So this, in addition to the kind of the tier twos that are out there in the incumbent telcos that are going after CAF2 funding as well, they're also looking at fixed wireless to be able to get after this opportunity as well. So I think if you can sum it up, there really is a very aggressive push by a number of companies to offer services in these areas. I wouldn't all consider them adequate to meet the recommendations of the FCC. But generally, up until now, the current technologies delivered by WISPs have not always made it up to the levels that would meet these FCC requirements. So now let's talk a little bit about the capital expenditure. What does it cost to deploy an individual subscriber? And this, to me, is inclusive of generalized backhaul feeding to towers and general equipment needed to be able to cover a broader population from a tower location. So this is really averaging across the entire cost of a backhaul plus access plus CPE, the customer premise equipment. And typically we see today using our Mimosa gear, this ranges anywhere from around $200 to around $350 per subscriber, depending on the capacity you have on the tower. Now, we're actively moving to get this far further as we reduce the cost of our long-range client technologies, but this represents a fraction of the costs of getting fiber out into areas, which now costs well over $1,000 per subscriber. So these are really the kind of key business elements that we look at. So now what I want to touch on really is kind of the key architecture techniques, looking at how do we build out a rural solution. So as I was mentioning, rural starts with delivering bandwidth into these serving locations, which are typically towers. These are really, in the past, have been typically unlicensed point-to-point backhaul links. A lot of people have used 5 gigahertz for this, and this is something that Mimosa has been delivering, I think, fantastic quality products in for the last year and a half. But there's also a big trend now as wireless ISPs are going up in speed and wanting to improve their long-term reliability and resilience to interference, and also make space in the spectrum for multipoint. They're moving towards licensed technology, and that can be the 11 gigahertz technology and licensed Part 101 in the United States, but also higher frequencies, and people are moving even up to 60 gigahertz and 70 gigahertz products for shorter range technologies. But generally speaking, there's going to be a mixture of backhaul, of course, feeding towers. I'm only showing one radio here, but typically we're seeing redundancy built in or multiple paths getting to the tower as well as being a very strong trend. So from that point, I'm not showing all the details here, but interconnecting typically to a switch at the bottom of the tower. Then comes the access points connected up to sectors. And these sectors typically are what we've seen statistically is about, I would say about 5 years ago, our wireless ISP partners were roughly 7 to 8 miles on average away from their typical subscribers in rural areas. In the last 3 years of progression since then, our wireless ISP partners are now telling us no, they're really between 3 to 5 miles from their subscribers in rural areas, which means they've been putting a concerted effort of getting closer to the subscribers to provide more serving points to get more capacity and more speed to the subscriber. So typically, what we see on average in the deployments and all of the testing that we've done, really we see people in the about 30 subscribers per sector, up to about 50 subscribers per sector, and I think that's a pretty good target. And this is about where we've set our quality metrics, and our business case is around that 30 subscriber limit. But you can go higher than that. I think that's going to be important to go higher than that in developing markets as well, where they're much more cost sensitive, and you're going to want to divide through the economics of an access point or a serving location by more subscribers. So now the question is, okay, I have more subscribers than that and in different directions on the tower. How am I going to do this? Well, of course, I'm going to want to add in more sectors. And this is where our synchronization technology comes in. So looking kind of from an eagle eye view down, you have a number of different access points now pointed in different directions. This is going to be very basic for most of the WISPs that are here. So bear with me. We'll get to the meat of some of the tech in a little bit. But effectively, I can now put back-to-back sectors with able to reuse the exact same channel. And that's of course important because the spectrum that we have is quite limited. So we want to be able to take a channel and not use that channel only once on the tower. We want to be able to use it at least twice. And if we get tighter and tighter beam widths, as there's a bunch of new antenna technologies coming out that have incredible isolation on them, we'd be able to actually reuse that bandwidth even more so than twice on a tower. So this is a really great increase of spectral capacity and number of subscribers that can be affected here at this point as a result. Okay, so let's dig into the details a little bit. I'm going to start off with the A5C product. The A standing for our access products, 5 standing for 5 gigahertz, and C standing for connectorized in our naming acronym. The A5C has just actually hit the market. Our first users started receiving them about 2 weeks ago for general production. We have been testing it in the field for obviously over about 5 to 6 months, at least with our beta partners. And it's been a real game changer in a lot of different ways. And we're going to talk through the different pieces of technology that come along with this. But I can generally tell you that we have a lot of people that are going to want to target very long range clients. We've heard people asking for up to 20 miles, and this is going to be the access point that will be able to do that, and it will be able to handle distances that are very short as well. Now, we typically do not recommend extreme short and extreme long together. That's usually not a good thing for access points. That's also why we've seen a lot of wireless ISPs get closer and closer to their subscribers so that they have a more general density of subscribers in the same area. But generally speaking, this is the product that we're going to recommend for really anything more than 1 to 2 miles. And we have other products that will work very, very well on those shorter distances for the urban and suburban cases. But this is really where you want to go from tower serving locations. So we can get you to the spec sheet, so I'm not going to go too much into detail on this slide. I'm going to go into the different features and benefits of these as we go through this, as we go forward here. So first and foremost, the things that we always do on our products is we make them very, very rugged and really, telco grade, especially to deal with outdoor considerations. So the A5C is IP67 rated. It also comes with gas discharge tubes. What does that mean? It's electrostatic discharge protection on the Ethernet ports. This isn't a powered over Ethernet product. So we want to provide the best possible protection up on tower locations that are constantly seeing static and ESD discharge. And also extended temperature performance. So we've really done a great job of making this a product that will have a very long life. You'll notice kind of the effort that we've put into for heat dissipation and all the things that we're going to deal with in incredibly high temperature environments and low temperature environments as well. So this is, I think, something that any WISP is going to enjoy, that we've really designed this for a very long life of a product, where I think there's a lot of lower cost stuff in the space that just doesn't take into consideration the long-term impact on components and heat and things like that. I think the biggest benefit that you're going to realize is in addition to capacity is what we call beamforming. And most people that are familiar with wireless are just now getting familiar with what beamforming does. with these four antennas that are built into in streams that are built into the A5C, we are now using a new technology that literally lets us aim the radiation patterns in thousands of different combinations of directions. And what that lets us do is when we know the location of a client, it's going to let us, of course, aim towards that client. But the big benefit to that is that the focusing of that energy and the processing of these streams now gives us an extra 3 dB of signal, which in the wireless world is 50% stronger than before. So this is a huge advantage to basically being able to control the radiation patterns from one perspective and get increased signal as well. The other element that I think is fantastic about this, as you'll notice, we're now able to create these finger-like beams that allow us to push the beam in a very specific direction, and the clients are literally telling us at their home locations what the best location from a wireless RF perspective is to aim back towards them at. And that's a big deal for us to be able to reduce unwanted radiation in certain directions. That's important both from the health of the air and trying to keep as little radiation where you don't need it, but also for the final concept here, which is the concept of being able to have multiple different clients being able to be transmitted to at the same time. And this is what we call multi-user MIMO. So our antenna technology is completely passive. What do I mean by that? You don't need any specialized antenna technology with any kinds of beam steering. There used to be technologies that required that. This beam forming technology simply takes four antenna strips that are inside these enclosures, and we'll show you some pictures of them a little bit. And simply put, this is a digital way for us to be able to control the four different streams in different directions, amplitude and modulation, and this is what's giving us the phase shifting that we need to be able to aim these patterns. So this is going to allow us to create nulls in one direction so that we can start shooting streams of MIMO streams and bandwidth in other directions from the same access point. And that's a really critical concept from a spectrum reuse perspective. I'm able to get more bandwidth in the downstream direction is part of this inherent design. So synchronization, I think, is really not very well understood by a lot of folks. This is a great example of one of our clients in the field using, in a rural situation, our GPS sync technology. And this one allowed us to be, in this particular one happened to be using our backhaul, getting us four different directions using the same channel in our backhaul. And this is really a critical concept, as I was mentioning, for tower capacity. So as we are trying to put more subscribers on, we don't want to be taking up a channel with every access point that's put on. And this is, a unique technology that's combined with our MIMO technology now to really deliver the best possible speed, performance, and spectral reuse at a network-wide and a tower-wide facility. So I think this is a really critical concept to really understand. And really fundamentally, it's in the access point world or in the multi-point world, it's really for back-to-back synchronization. So what we're doing here is making sure that the antennas are designed with good enough quality from front to back ratio that they won't interfere with the radiation of the access point on the other side of the tower. And we also are, of course, using the TDMA and GPS synchronization technology. We also get asked a lot about what happens if we may not be able to get GPS or not as good of a GPS lock. We do only need 3 satellites to get a lock, but we've also put in the GNSS or GLONASS technology, which doubles the number of satellites that are in the constellation in the sky for us to be able to derive our critical timing for. So we've had very, very good success with this. We've made it super easy by building the GPS into every radio on the tower locations, so you don't need to have an external dongle to receive signal. We've, I think, had very, very good success with this approach. It keeps it easier, and it also keeps birds from chipping away at cables and things like that might cause problems as they look like attractive little cables up on the tower that birds like to eat. Okay, so looking at antennas, I'd like to introduce a couple of different antennas. We get a lot of questions about antennas because this is a new technology. This is the first 4x4 antennas for the 5 gigahertz wireless space for fixed wireless. So we decided to partner with well-known, very high-quality antenna partners. The first one that we did so with was KP Performance Antennas, based out of Canada. And they built the first 4x4 antenna designed around the very specific design criteria that we had to make synchronization and co-location work really, really well. So their first product on the market is now available, and it is, I think, kind of the top end of the market from a performance perspective. We have a number of different antennas which are going through our final qualifications and moving their way into the distribution channel. The first one that you'll also see on the channel is also from a company called MTI Edge. MTI will also have a 65-degree antenna coming to market very soon. It's much more of a cost-effective play and has very, very good characteristics for synchronization as well that we've also tested. So we are getting in the habit of doing now qualification of antennas that we will recommend. And you will soon see a site launched by us around doing much broader recommendations around products that work really well with Mimosa gear. The KP product comes with an integrated mounting bracket to make it easy as well to mount up the A5. So the configuration I was mentioning earlier, so the first one, this X4 antenna from KP is a 65-degree antenna as they rate it, which really realistically means if you really wanted 360 degrees of coverage, you would want to put up to 6 of these on a tower. So really that could represent at very high speeds capacities somewhere in the range of 250 to 300 clients of really high performance. And now you're talking about 100 meg plus speeds for people around those kinds of capacities. So this would be an ABC configuration, as we call it, where you would have 3 different channels being used across the spectrum, and then back-to-back reutilizing on GPS synchronization. KP also did introduce, for space-saving needs for capacity, a new product called the X8. The X8 is coming to production. It's not quite on market yet, but it is coming very soon. This lets us mount 2 A5Cs to the antenna and leverage basically the space savings. A lot of towers, as most WISPs are aware, have to pay for the space for each antenna. This allows you to double down the number of antennas connected up to, the number of radios connected to the antenna. That's, I think, a key thing for people that are trying to add super capacity. So if you want to run multiple channels, so I can now run multiple channels in the same sector and get twice the capacity on different channels. So this is a really keen way of really upping capacity on towers beyond the single X4 antennas being GPS synchronized. So similarly, this is exactly what this would look like. So you would easily be able to put up these 12 access points. It's probably a little bit more than some WISPs are wanting to spend on a tower, of course. But for guys that really are going after high capacity tower serving locations and also multiple channels in a particular sector for client diversity, I think this is a really interesting solution. So moving into the client side. So getting beyond probably about 3 miles, 4 miles range, the C5 product, as some are familiar with, is the first product that we came out with that was an integrated antenna. And I'll show you some pictures of that in a moment, but that distance isn't necessarily long enough for rural applications that are going out to these longer distances out beyond 5 kilometers or so. So we created the first product for long range called the C5C. Unfortunately, this product is not yet ready for market. We're looking at that, closer to the end of the year. But generally speaking, this will allow you to bring your own antenna. This would allow you to connect up virtually any parabolic antenna or various types of reflector or panel antennas. We are working with antenna manufacturers to come out with some very, very cost-aggressive options to keep this as a lower cost performing client device. We know there's big demand for 25 dBi plus antenna solutions that are low cost. So we are actively working towards that to really keep the cost down on the client side. But this effectively will give you the capability to do that. Now, in the meantime, as people are deploying over the next couple of months, and this product may not be available yet, we have a lot of people still using their existing clients in the field. And I think this is a critical feature of the platform, is the compatibility with legacy 802.11n based equipment from third parties. So if you've already deployed rural equipment using 11n based technology, you can put it in compatibility mode with the A5C and use those at very long distance. So we recently put out software that fully supports that. So I can now do very, very long distance using in the field 11N gear. And if it supports true Wi-Fi based 11AC, we can also support that in the short-term transition to be able to handle long-range clients. So there is a solution in the near term, and those products will be coming to market soon after that. So we also have worked towards on all of our products where we could supporting public safety applications. Additionally, here we are pushing the A5C and our client products towards the certifications to support public safety 4.94 to 4.99 band. This is a critical band for municipalities and safety organizations. So I don't want to dwell too much on this, but it's important to know that we put the effort here into supporting these. So when we go into these public-private environments where we're trying to support critical life-saving applications and safety applications, that we can get dedicated spectrum for those. And that is actually supported directly in the radio as is. All you need to do is register to use these licenses in your account with us on our cloud system, and you'll get access to those frequencies, assuming that you have a proper application and an FCC license to do that as a public safety agency. A couple other things that we've included. We get some really great reviews on this feature. Is the ability to we've put in the 2.4 gigahertz Wi-Fi purely for the purpose of getting easy access up to an access point from the ground. And this is so if I want to be able to make some configuration changes or I need to adjust heading directions on things, it's very easy for me to use my smartphone to talk directly up to the device. So this is really an ease of use feature. We have some WISPs that prefer not to have that on. So that's something that you'll be able to turn off if necessary. But it's something that a lot of ISPs have really started to like because the ease of use of having a single-handed smartphone, being able to get information for the device is really nice at the top of a tower. Okay, so I'm going to transition a little bit to talking more about kind of what it's like to install a home in a subscriber environment. And so what I'm showing here is kind of the ecosystem of different pieces of the equation that you need to think about when going after a Mimosa solution on the access side. So here I'm showing a number of different products that go together to be able to make the installation easier. So starting at the top, we have the client radio, which would either be the C5 or that connectorized C5C product that I mentioned earlier. And that would be then attached to a mount. Our favorite mount that we use is the what we call the Flexi mount. The Flexi mount, as you can see here, can attach to siding, but it also has attachments to poles if you need to attach to a pole on the roof. And it can work at any angle. So it's quite flexible to be able to be put on angled roofs, angled surfaces, vertical or horizontal poles, or even angled poles. It's really the most flexible mounting solution on the market out there at a very low cost. And then also critical to every installation, we recommend for grounding purposes and for protecting the inside of the home, putting in what we call a NID or a network interface device. And this will help to provide ESD protection or so that lightning, for example, if for any chance that the radio got hit by a lightning strike, there would be no risk or liability to you that there was any power or surge brought into the home. And this is a very low cost item to be able to add on, and it is within the right approach with the regional and national electric codes to go do this. And of course, per electric code, you would go straight to ground as well. A lot of WISPs don't like doing this, but it's what would be suggested as following the right codes. You can also, of course, run a wire directly to the utility entry point of the home, which is also grounded, whether that's the plumbing and electrical area where that enters the house. Now, on the inside of the house, we've also developed a product that we're very proud of that is really clean solution for delivering a managed Wi-Fi solution for in-home. And this is what we call the G2 product. This is designed to both power the device on the outside of the house, but also provide integrated Wi-Fi for the consumer on the inside of the home. Now, the cool features with this really are that it's simple, clean, it's not multiple devices, but most importantly, it has built in a complete health diagnostic to determine the difference between the constant problems that people have with Wi-Fi inside of their homes and detecting the difference between a problem with the network. So in capabilities here, we are constantly checking the network health from this device and reporting back to the wireless ISP and notifying them when we're seeing really bad behavior and performance. And also, we're able to have the ISP come in and look to the inside of the house at the signal levels for particular devices. So that if a customer calls with problems with their network, you're able to tell if it's a network problem or if it's a Wi-Fi problem, and then help them understand with specific devices that have specific signal level problems, and also recommend putting repeaters into the house. And you can put multiple of these devices distributed around the house and help them place those devices very easily. So now we're really embracing helping the subscriber understand the true health of their internet. And their perspective is if Wi-Fi doesn't work, internet doesn't work. And that's now becoming the responsibility of a good operator to help them get better Wi-Fi so they don't think that your service provider service is very poor. Okay, with that, I'm going to jump a little bit into the last client device, which is the C5 device. And again, we're recommending this only up to roughly 5 kilometer ranges because it is only a 20 dBi device. So we see this as more critical in the suburban applications. We will see people using this with the A5C product in probably less rural areas, I should say. But this is really kind of the mainstream client for short range. And is a kind of a very simple reflector-based design. So you'll see it's a very clean and easy design. Roughly speaking, it's about the third of the size of a typical satellite dish. So it's quite compact. So these are kind of the entire pieces of the ecosystem that we have. So I think so far what we've really touched on is all of the kind of the business drivers to what's happening in the rural community with both the subscriber need, the business opportunity, and the capabilities that WISPs have today. We've talked a little bit about the new technologies entering the space to be used at tower and sector locations. We didn't talk too much about backhaul because we spend so much time typically talking about backhaul. And then we talked a little bit about the subscriber technology and what it takes to install this stuff on a house. So hopefully, I'm sure that Lee has a number of questions lined up here. Hopefully this has inspired a few questions to come forward, and we'll do our best, given the time, to be able to answer as many of these as possible.
First question here is around the beam width of typical sectors for the A5C.
So I think that what we're seeing statistically, and we put up a bunch of polls on our community to kind of see what people are asking for and needing. And also, we had asked the antenna manufacturers regionally, because it is quite different in the Midwest versus the South and the West, what do they sell best in each different areas? And the answer that came back was that 65 degrees is really the kind of go-to initial choice. And as WISPs have been running out of spectrum, they've been getting narrower in their beam widths on the antennas. Now, I think that because we're providing more capacity at the radio and GPS synchronization, it does allow us to get more subscribers onto these access points, I think, than some people have been comfortable putting on them in the past. So I think that some people have been moving down to 30-degree antennas, but I think that's a little bit overkill. So I think the sweet spot is 65 to start with in kind of good density markets. And then for much lower density markets, we're definitely seeing the need for 120 degrees. And of course, the old school traditional 90 degrees. So you will actually see a number of different offerings coming out, I think, over the next 2 months for 120 degree and 90 degree options from our antenna partners. But 65 degrees is really the first 2 or 3 antennas that we have coming out are targeting that size.
Next question is around GPS synchronization and that working between APs and backhaul radios.
Great question. So today we started off with a GPS synchronization timing window. For those of you familiar with it, we are deciding basically how much speed do we want to provide in the upstream and the downstream direction. So in our backhaul radios, we introduced the concepts of 50-50 or 50% upstream and 50% downstream. And then also the 75-25, as we called it, which meant 75% down and 25% up, and vice versa, 25-75 up, down. In the access points, we aimed to start with initially with a 50-50. So the A5C will be compatible with the Mimosa backhaul 50/50 configuration at the 8 millisecond time windows. So these are the larger time windows right now. Over time, we will be introducing smaller time windows, and I think that we will be optimizing as well to go towards in that 75% range up down as well. So this is something that we're going to be working on to continue to add more compatibility feature modes, but 50/50 8 milliseconds will be the first compatibility point.
Next question is around the G2 and how that could be used to cover a larger home.
So the G2, as you noted from the name, too, is a 2 gigahertz product. So that is inherently using the 2.4 gigahertz band, which does give a bit better coverage, but as many people would note, has a little bit more noise because it goes farther, and you might be picking up your neighbor's noise floor and interference. So generally speaking, what we've done here is we've built up a very high performance antenna, although it looks very small and compact, is a very strong antenna and nice power output. Now, what we've built here is the ability for you to measure the signal level of a client in the home, whether you're on the phone talking to a customer when they're at home complaining about Johnny's phone in his bedroom isn't working well. You can tell them to go in there with that, and you can remotely monitor it and say, yes, we need you to put an access point or a repeater, another G2 device directly in, somewhere in between those 2 points, and that would be your service point. So how do you do that? How do you connect between them? Well, we've made the G2s very easy to simply plug and play a second or third one, where you literally plug it in and it zaps the configuration of the original one and copies it onto the repeater device, and then you simply place that device in the other part of the house. Very, very simple, and great that we've also kept the cost of this product quite low. We introduced that product at $49, so we've tried to keep this very aggressive and very feature rich from the ISP's perspective of being able to help the subscriber and monitor their connections.
A question here about our experience with the A5 and beta testing in relation to foliage and the ability to penetrate foliage.
Great question. Foliage, as most people will know, and granted, we're talking about rural here, and we're talking about 5 gigahertz. A lot of people in the rural space are leaning towards, for heavy foliage environments, LTE bands and 2.5 gigahertz to be able to get a little bit better penetration. That being said, though, with the beamforming that we've been getting on these antennas and our experience with in general has been that we've seen very good signal increase on a lot of the places that you're familiar with already deploying in. We've been getting much better SNR. So I think that there is improvement here, but I don't want to be telling you that this is a major game changer for foliage. You're not going to be blowing through tree stumps. You're going to definitely be able to make it through some leafy areas, but at some point, if you're not close enough to get enough power through those, you're going to struggle. So I would say, expect it to do equally or better, but don't expect it to be orders of magnitude better in 5 gigahertz than you're used to.
Okay, that's all we have time for. Thank you, everybody, for taking the time today. Really appreciate you taking a chunk of your time out of your day to come and listen to us. Thank you to Jamie for joining us and presenting. And look out for more of these to the point webinars in the future. Thank you.
Thanks, everybody.